Merhabalar, herkese iyi günler diliyorum. Hoş geldiniz webinarımıza. Bugün sizlerle önce kendimi tanıtmak istiyorum. Tekne yangın olarak ve TÜYAK üyesi olarak yangından korunma sistemleri konusunda 30 seneden uzun bir senedir bu faaliyetlerde bulunuyoruz. Sprinkler sistemleri, köpük pompaları, pompalar, köpük sistemleri, su bazlı, gazlı sistemler olarak. Bugünkü konuşmacımız Simon Barrett, Viking firmasından özgeçmişini anlatacağım ama ondan önce ben akış programını sizlere tekrar iletmek istiyorum. Gelecek programlarda, evet, gelecek programı olarak 9 Mart 2024 Cumartesi günü lityum iyon pilleri sistemlerinde yangın söndürme semineri, eğitim seminerimiz var. 18 Nisan 2024 Perşembe günü binaların yangından korunması hakkında yönetmelik uygulamaları eğitim semineri Diyarbakır'da. 25 Nisan 2024 Perşembe günü damperler özellikle Avrupa standartları ve NFPA karşılaştırma webinarımız var. 16 Mayıs 2024 Perşembe günü endüstri testlerde yangın güvenliği eğitim semineri Eskişehir'de. 13 Haziran 2024 Perşembe günü acil durum yönetimi ve yangın güvenliği eğitim semineri Konya'da. Bu şekilde programımız bulunmaktadır. Ben bu arada Simon Barrett özgeçmişi hakkında bilgi vermek istiyorum. Simon Barrett, Viking Grup bünyesinde köpüklü söndürme sistemleri ürün müdürüdür ve şu anda Birleşik Krallıklar'da yaşamaktadır. İşletme finans alanında eğitim almış ve 28 yılı aşkın yangından koruma deneyime sahiptir. Simon kariyerine EMEA ve APAC bölgeleri için dahili satış ve dağıtım üzerinde çalıştığı Springer üreticisi Central Spray S firmasında başlamıştır. Viking'in Birleşik Krallık Organizasyonu'na 1999 yılında 2 yıl dış satış temsilcisi olarak katıldı ve ardından 12 yıl bölge satış müdürü olarak görev yaptı. Bu görevi olağan ticari sorumluluklar dışında pazarlama ve teknik destek görevleri de içeriyordu. Simon, 2013 yılında köpüklü söndürme sistemleri ürün müdürü olarak mevcut görevine geçti ve Viking'in genişleyen sabit yangından koruma köpük ürünleri serisinin satış, destek, pazarlama, teknik destek, dokümantasyon, Ar-Ge ve sertifikasyon organizasyonlarından sorumludur. Ve Simon Bey, şu anda sunuma başlayabiliriz Simon Bey.
Thank you
Yes,
very much.
Mr. Simon Barrett, you can start for your presentation. Thank you.
Okay, thank you. Good afternoon, everybody. It's good to be here to speak to you today. For those of you at the TUAC conference in November, I spoke in more detail about the background to legislation and PFAS and chemistry. And what I'd want to do today is just move the topic forward a little by talking about how we actually transition systems from fluorinated foam products to fluorine-free. So we're going to have a quick refresher on foam systems very quickly, a quick refresher on the background to the PFAS issue, and then we're going to move on to the bulk of the presentation, which is looking at different components and the different considerations that we need to have when transitioning our foam systems. So as a reminder, we're typically using firefighting foam in systems where we protect against the fire and spread of ignitable liquids. Okay, today's presentation will be all about fixed fire protection. So that's pipework, valves fully installed, as opposed to mobile firefighting with fire brigades. We're going to use foam because often water alone is not effective in the protection of these ignitable liquids. Or it might be that we can use less water, less density, by enhancing that water supply with foam. Foam systems are also used where there's no possibility to provide adequate drainage or containment of spilt fuels. So here is our typical fixed system. We will see this diagram a lot today, with all different elements of our fire protection system. And we will have a water supply, like with a standard deluge or sprinkler system. We then have a foam concentrate reserve, a device, a mixing device, which is the proportioner, which mixes water and foam concentrate in a certain ratio to give us a foam solution, which is then distributed throughout the fire protection network to different risks. So loading areas, large storage tanks we've got there. We've got shelving in a warehouse situation, or storage of ignitable liquids in barrels, for example. So one of the benefits of a foam system is that it's quite economically scalable. What I mean by that is we can protect large areas with a foam system without it becoming very cost prohibitive. So although the foam concentrate itself is a chemical, the fire extinguishing mechanism is purely physical. And what we want to do is take away the fuel from that fire triangle. So when we have a Class B ignitable liquid fire, it's actually the vapors escaping from the liquid that's on fire, not the liquid itself. So we use the foam as a physical blanket that floats on the surface of these ignitable liquids to stop the vapors from escaping, and thereby we remove the fuel from the fire. We also have a cooling effect coming from the foam solution, the water temperature. That helps to cool down steel containment that may later give us issues with the foam blanket. So next, a very short video just showing that actual scenario. Here we're discharging foam during an approvals test with a laboratory, and due to the surface tension and the specific gravity of the foam, that is going to float on top of the ignitable liquid. And you can see where we've got a foam blanket, we've stopped the vapors from escaping, so we get fire extinguishment. That was just a very, very quick background to the main areas where we're using foam, just to set the tone for this presentation. So next, PFAS. What about the PFAS issue? So PFAS is a group of chemicals. So the group is per and polyfluoryl alkyl substances. That's a group of thousands of different chemicals that are used in various types of industry to enhance the performance of a certain product. So, for example, PFASs are used in food packaging to stop the oils and greases escaping from the packaging, like with a burger wrapper, stain-resistant clothing or stain-resistant furniture. If we spill liquids or even solids on those materials, due to the coatings that material has, those fibers, it makes them resistant to staining, and often we can wash out any spillages that we have. Also, non-stick cooking utensils, they're all enhancing the performance of a product, and firefighting foam is nothing different. So firefighting foam benefits from PFASs because it makes the bubble structure stronger. It also makes it resistant to a certain degree to flame and heat, and also the chemical reaction with those different ignitable liquids. The problem with firefighting foams is, although we account for a low percentage of PFAS consumed or used every year, because of the way we use fighting foams, there's a very high chance it will get into the environment. When there's a fire, we have a discharge that runs into drainage, which can find its way into rivers, streams, and land. So that's why there's a particular issue with firefighting foams. And these types of PFAS, some of them used in foam, we've got PFOA, we've got PFOS as well. These are different types of PFAS. They have been linked with detrimental health effects, and because they don't break down in the atmosphere, they're not biodegradable. They last in the environment for a very long time and also referred to as forever chemicals. And as the planet gets more sustainable, environmentally conscious, these chemicals, we don't want to be using them anymore. And that's why legislation is increasing. However, we still need to extinguish fires. So we're now working with and developing foams without these PFAS chemicals, called fluorine-free foams, because they don't have this negative environmental impact. So this move to SFFs, it's not driven by the usual market forces in terms of improved performance or lower costs, or it's easier for a manufacturer like us to make. The reason we make these changes is due to environmental concerns and now increasing regulation around the world. I just want to make the point that even fluorine-free foams cannot be considered environmentally friendly because they do have an impact on the environment. The key thing to remember is this is a short-term environmental impact rather than a long-term impact. We see different acronyms or references for SFFs, F3, FFFs, fluorine-free, PFAS-free. Whenever you see these marketing words, it all effectively means the same thing, that it's a foam concentrate manufactured without added PFAS chemicals. For those of you involved in foam systems, you may recall over the past 10 years that the industry already moved types of foam from what we called at the time C8 to C6. This was if you like, cleaner type of PFAS, but due to the increase in restrictions, even this cleaner type of PFAS is not considered acceptable anymore. So therefore, we've got new systems and the modification of existing systems with SFFF. That's increasing as the new legislation comes into play. I won't go through this long slide of a timeline of foam, but the two key elements, I guess, for us in Europe are the EU's legislation on firstly C8 foam, which is now live. So from January 2023, that could no longer be used if it couldn't be contained, which means not sold, it means not used, which means it should have been removed from systems. And last year we expected new legislation for PFAS in all firefighting foams, but that's actually been delayed due to all the public consultation. So we expect that sometime in 2024, and that will again have around a 5-year derogation in which industry will have to comply and stop using those types of foam concentrates. Okay, so that's the basics on how foam is working, and then what this topic is related to why we need to change foam. So once we've made the decision that we want to change our foam system, or we want to design and install our new foam system with SFFF, synthetic fluorine-free foam, there's several different elements that we need to consider. If it's a new system, it's relatively straightforward. What I mean by that is it's very similar to designing a system with fluorinated foams from the past. So we're going to select a design standard. We're then going to select a product supplier or suppliers. We would then design that system according to the supplier's product densities, approvals, and of course the design standard. And then we're going ahead and installing the new system. I know for the contractors on the webinar today, that's still a very complicated and time-consuming process. But because we have effectively a clean sheet of paper, it's much more straightforward and standard. When we look at transitioning projects, also called retrofit, for example, or replacement of systems, renovation of systems, these are much more challenging because we're dealing with an existing system. We're dealing with an existing scenario. So some of the topics that come up, and due to the time we've got today, I can't go into detail on all of these, but these are some of the key words and topics that always come up when we talk about these transition projects with our clients. I think fuel is an important one. We're going to come back to that later. We want to know, is the existing system, is that compatible with the new foams as well? So we're going to look at that later. A lot of this is what I call an unbudgeted cost. So when the end user installed their fire protection system 5, 10, 15 years ago, they didn't really expect to have to replace it again in the future. So this is often a surprise to end users about actually how many different topics we need to assess. It's not just a case of emptying the tank with one foam and refilling it with fluorine-free foam. So when we start working with industry, with insurers, with end users, there's some key questions that we like to ask and understand. So shall the transition comply with a specific design standard? I think this is the most important one because our advice has got to be based on that particular design standard. If there's no design standard, I would suggest that's probably a bad idea. And at that stage, a design standard should be adopted. That could be NFPA standards, it could be FN Global risk occupancy standards, or it could be the European standard, for example, or there may be local standards over and above those more international standards. Is there an insurer or AHJ involved that will have their own requirements? So what we've seen over the past few years is that insurance companies are getting much more involved in requiring their clients to change these systems. But for example, if an end user discharges a system that's got non-compliant or illegal foam concentrate in it, obviously that could be a risk for the insurance company as well. So we do see insurers involved more and more. Will the transition use system components tested and certificated together? Well, if you are designing to an NFPA standard, for example, that's a prerequisite that you must use listed or approved equipment that's been fire tested. Even the European standard will have more requirements related to products tested together. So this is a key one to understand. The reason we ask this question is it will give you a more compliant system, but it will limit the choice and it may increase costs. So at the early stage, we need to understand if this is a requirement of the end user or the insurer. Has the end user already defined a specific type of foam concentrate on their site? So we see this particularly in aviation and oil refineries, for example, where they have their own fire brigades on site already, and they will have chosen a foam concentrate. But of course, from my point of view, I think there's something very different between a fire brigade and a fixed system. And a fixed system has to sit there and work without any human intervention in case of a fire. So for that reason, it doesn't automatically mean that the foam that works well on the fire truck will also work well in a fixed system. Another key one is which fuels are going to be protected. What's the commodity? And we're going to come back onto fuels more later. One difficulty, I would say, or one question everybody asks, and it's very difficult to give an answer, is should all traces of PFAS be eliminated from the system? If that's the case, and the legislation or the proposed legislation in Europe is unclear on this, and it's very difficult to get a definitive answer. But if during your transition you don't want to risk any future issues with trace elements of PFAS, then a suitable cleaning or even a partial replacement of pipework might also be required. This is quite a complicated area, and we won't go into that today, the cleaning of systems. Here, quickly in red, we've just got, I mentioned earlier, NFPA 11, for example, the foam standard requires the use of devices and foam concentrates that have been tested together in fire tests, but also compatibility tests between them. And FM have a similar requirement in all of their design standards as well. This is a slide that often people do not know exists, so I'll just take a minute to explain. This is a typical manufacturer's approval. This is actually an FM approval, and for a particular foam concentrate, as a manufacturer, we need to test different proportioning systems, different discharge devices at specified densities. So on the FM website and on UL's website as well, you can go in, have a look at that specific foam concentrate and see all the different pieces of hardware that's approved. But importantly, you will also see design information there as well. So there's a lot of information in these online approvals. Both FM and UL are free of charge to access. So coming back to our system, we're just going to go around different parts and focus on individual products and scenarios. So I mentioned I would come back to fuels. In my introduction, I explained that firefighting foams benefited from PFAS because it made the bubble structure more resistant, more resilient to heat from the fire and flames, but also the actual chemical reaction of the Class B ignitable liquid that we're protecting. And PFAS helped us a lot with that in the past. But with the removal of PFAS, we've had to find other ingredients that we use to maintain fire performance. And I have to say that probably 5-6 years ago, fire performance, there was a difference between fluorinated and fluorine-free. But in terms of fire performance now, we are seeing products on the market that are giving very similar performance and passing the same tests that were passed with fluorinated foams in the past. However, some of these fuels, and MEK is one of them, methyl ethyl ketone. This is used in a lot of industries for cleaning surfaces before production. It dissolves and destroys resins, adhesives, rubbers, and it also has a destructing effect on firefighting foams as well. What we had with fluorinated foams was a long history of proven performance, extrapolation, which means we had data for one scenario that we could use in another scenario with a certain amount of confidence. What we've learned as an industry, and I don't just speak from my company's point of view, we've learned that we shouldn't automatically assume what worked in the past will work in the future. And therefore, there's an unprecedented amount of fire testing happening within our industry from many manufacturers that never happened in the past. And I think one of the key things for if you're involved in transitioning a system, if you're a contractor involved in advising your client, it's important to work with a foam concentrate manufacturer that's capable of not only making these assessments based on science, but also backing that up with fire test data. Because what we see is that science tells us one thing and a fire test can tell us something else. So it's a combined picture that we use to give guidance on minimum application densities, or we use our FMUL approval data to give that density information. So, as I said, these SFFs are more sensitive to fuels than in the past, and this is not manufacturer specific. It's happening across many different manufacturers because they've all taken away those fluorinated surfactants without finding a direct replacement that's biodegradable and more environmentally conscious. So that means that we need to ensure that we've got a way of performing some kind of test on these chemicals, but some of them cannot be handled outside a laboratory. Some of them we just cannot fire test because they're too dangerous. Fire test centers won't allow fires with those products. So we need to find other ways of making an assessment. That can be done through chemical science assessments and evaluations, but also it can be done through small scale fires or small scale compatibility tests with the foam. So I'm not going to go through this in detail, but the top slides show a typical fluorine-free foam and SFFF on MEK. And what we're doing here is just testing the compatibility. This does not by any means replace a fire test, but we're making up a foam solution. We're shaking that in the beaker that you can see in the first slide, and we're applying that foam blanket. Now you can see that after 19 seconds, that foam blanket has started to disappear, and this is even without fire. We then apply a second shot of foam after 25 seconds, and by 80 seconds, that has disappeared again. So that particular chemical is designed to destroy the gums and polymers, which we happen to use in firefighting foams. When we look back on a fluorinated foam, you can see at the bottom, the timings are quite different. So as an equivalent test, we stopped the test at 60 minutes because it was just getting boring. You can see on MEK that foam blanket is still very much intact. Now, what I want to conclude with this is not that SFFs don't work. It's that we need to understand where they're strong and where they're weak. And that only comes through testing. These products can be overcome, normally through density. So we just need to increase the density of the foam application to counteract that foam destruction in order to get a extinguishment during a fire. It may be that we mix at 6% instead of 3%. So we're using twice the concentrate. That doesn't always work, by the way. So again, lots of research and testing is required here. So moving on from the fuel, next, the discussion normally comes to the foam concentrate. And again, we've got many things to consider. What kind of system is it? Is it fixed or is it a mobile system? What's the fuel? What type of discharge device do we have? In our foam industry, we have a mixture of devices that are made specifically for foam discharge in mind, and then we have products that are not specifically made for foam. They're more designed for water application, but used in foam systems, like a monitor or like a non-aspirated standard sprinkler head. Typo there. How will that foam be proportioned? Do we have a proportioning system that's capable of dealing with that foam? Do we need an approval or certification on the foam? Hopefully, yes, but sometimes that's not a requirement. What design density do we need to apply for that foam as per the design density guidelines? Do we need environmental reports and certification? This is something that's very much increasing, that end users, before they will commit or purchase a foam concentrate, they want to see that it really is PFAS free. So we have some end users making their own private tests, or some may require specific approvals like green screen, for example, that's screening a foam manufacturer's production process to confirm that there's no additional or no intentionally added PFAS chemicals. So in reality, because of the choice that's available of fluorine-free foams at the moment, it's more checking that the available products fit all these criteria, rather than looking at hundreds of different foams and selecting to choose the mission like we did in the past. So product selection has changed a little bit. Here we've got just an example what I mentioned about viscosity. On the left, we have what we call a low viscosity or Newtonian type fluid. That was what our traditional AFFFs look like. And then on the right-hand side, there we've got the fluorine-free foam, also called non-Newtonian, which you can see is a much higher viscosity, much thicker. And the reason that's relevant is the proportioning system we use. Those higher viscosity foams make it more challenging. And that's why we need to ask several questions during a transition project. So moving on from the foam concentrate, we then look at the foam concentrate storage tanks. So this is an atmospheric storage tank, normally used in foam pump, adductor systems, or if there's a water-driven proportioning pump, these atmospheric tanks are what's required. If there's been a change in the density, moving from a fluorinated to a fluorine-free, then that tank, you probably can't reuse it because you need a bigger tank anyway. Just as a side issue, I spoke about density changes. what we're seeing is we're consulting and involved in quite a few projects where the original design was not correct. So there is an increase in density, but it's because the original design was not correct, rather than the products today need more density. So it's not always the change of foam that needs it. It's due to either bad design in the past, or maybe FM or NFPA have increased the densities in the latest revision of their design standards. So there's more than one reason why densities can change. If the tank is large enough, however, it might be worth assessing if it's kept or not, because what we don't want to do is take a storage tank that had fluorinated foam in, empty it, and then refill with fluorine-free foam, because you will contaminate that fluorine-free foam straight away. So having spent that money on the new foam, that's not so much of a good idea. Cleaning with these industrial processes could well be more expensive than replacing the tank. So if it's quite an old tank, if parts have broken on it, if it's leaking, this might be a good time to replace the tank. In terms of an approved and listed solution, atmospheric tanks are not currently required to be tested with foam as part of a system. So in this scenario, you won't find anything that's FM or UL approved at this time. FM are introducing that requirement, but there's nothing on the market at the moment. Another storage tank system is a balance pressure proportioning system, commonly referred to as a bladder tank. So these are tanks that are kept normally under pressure, pre-charged, ready to activate, and the proportioning, the mixing of the foam is done using a Venturi device. Often we call that a proportioner, which mixes as the flow of water is flowing through the system. It will mix, it will dose at a certain percentage within the design parameters of that device. So again, if the current, or if the density doesn't change as part of the transition, then this is that the tank could be reused. If it's accessible, old, or damaged, for example, it could also be a good time to replace it. Speaking from my company's point of view, if it's a tank manufactured after 2010, that tank is still covered under our new fluorine-free approval. So if the density is the same, there is the possibility to reuse the tank. However, what we would require is that the bladder must be changed. There's just no way of cleaning that rubber bladder inside the tank to a level that will eliminate all traces of PFAS. The bladder should be confirmed as compatible with that foam. Again, that's what you get when you select a UL or FM approval. As a manufacturer, we have to pass long-term stability tests between the foam concentrate and the bladder. Those internal tubes might need to be changed if the end user or the AHJ requires a fully PFAS-free system. Again, any part of the tank that's in contact with the concentrate, so the outlet flanges as well, if they cannot be suitably cleaned, then they would need to be replaced. So you start to see that if it's quite an old tank, it's just going to be easier and probably more cost effective to replace the tank. Clearances will be required to work on the tank to remove those tubes. So again, if that's not possible, that's where the replacement of the tank might be required. Moving from the tank to the pipework, because all FMUL system foams are currently higher viscosity, And remember, in the past, an alcohol-resistant AFFF was also higher viscosity. So this is nothing new, but now all foams are with higher viscosity in these FMUL systems. I showed you the video earlier of the foam very thick, moving very slowly. That's because it needs to move through this pipework. So what we need to ensure is that we don't have the bladder tank too far away from the proportioning device. In our technical data page, and it's similar to other manufacturers, we don't want more than 65 equivalent feet or 20 meters equivalent feet of that pipe work that's circled. So the pipe to the tank containing water, and then the pipe running away from the tank to the proportioner, that needs to be less than 20 meters. We state 20 meters because that's what we tested in our FM approval. However, we are running R&D to see if we can increase that recommended distance in the future. One point I would like to make is that all proportioning systems have a issue, or let's say the critical thing to address is the pipe from the tank to the proportioning device, whether it's a foam pump, an adductor, a water-driven turbine pump. They all will suffer with excessive pressure loss in that pipe section. So looking at these different types of proportioners, we would always need to change the proportioner. We can't modify these devices in the field. So at the minimum, a new proportioner would be required. It might be that we go from a standard ratio controller shown at the top there. We might need to then use a wide range proportioner to help manage the higher viscosity foams. Again, that's the kind of advice and guidance that we can give, but it's a reality. In any case, the proportioner would need to be changed to be compliant with design standards and most insurers' requirements. We'd need to check if the density changes, then if we've got a higher flow rate, is the size of the riser still adequate as well? So there might be some pipework changes required there. Again, looking at a typical water-driven pump, when we're involved in the transition of these, we need things like serial number. We need very detailed suction line detail. We need to know the minimum, maximum flow rates and the foam concentrate that's intended for use. And then we work with manufacturers of these products to decide whether the existing unit is suitable, if it can be cleaned and made suitable for the new foam, or if a replacement unit is required. Again, that equivalent length of the suction pipework needs to be checked, and maybe the tank needs to be brought closer, or we need to remove some bends and valves. The suction pipework and return pipework should be changed. It's contained, concentrated PFAS foam for several years, so we would always recommend that the pipe is changed. Anyway, the valves, they should also be replaced, or if they can be thoroughly cleaned to eliminate traces of PFAS, then that could be possible. Again, cleaning is probably more expensive than replacing the valve. Okay. Due to time, a foam pumping skid like this is very much the same as the last slide as well, where we're looking at what's currently involved, checking if the speed of the driver for the foam pump is suitable, for example, and yeah, it's the manufacturer that's going to make the decision on that. Eductors, so eductors use all the flow of water to suck in the foam concentrate. They can only be used on fixed discharge systems, so on deluge systems. Normally, they're used as an inexpensive way of inducting foam. But again, if we have flow and pressure changes as a result of densities changing, the adductor will need replacing, or at the very least, it will need its internal components changing as well. And again, the foam concentrate line from the tank to the adductor should be replaced. Moving on to discharge devices. So non-aspirated sprinklers, I referred to earlier, they're designed to be used with water, not specifically foam. When we use non-aspirated sprinklers, it's much more challenging because they don't give us foam expansion. They don't increase the size of the bubbles. But with the right kinds of foam concentrate technology, the two can be brought together to work effectively. So when we're not going to go into the detail too much of foam qualities today, but the foam quality coming from a sprinkler is that low that we can't record it. So for this reason, this is the only discharge device that we test in real time in fire scenarios, like we see on the photograph here. So again, when we look at a retrofit project, we're going to want to know the specific sprinkler. Chances are, if it's not a Viking branded sprinkler, it's not going to be tested and approved with the foams that we offer, and vice versa. That will be a common situation. What density do we now require compared to before? Have we got the right kind of K factors? What pressure is available? The installation height can make a difference. Of course, the fuel foam type, and it may be that we need to move to specific testing if none of the, let's say, approved solutions available on the market fit that client's installation. Very quickly, I will run through this video. I guess some of you have seen it before. This is how we test sprinklers. So we have different commodities in the fire pan. That's a 4.6 square meter fire pan. It contains 230 liters of, in this case, acetone. And then we've got our non-aspirated sprinklers above, discharging foam. And you can see it's not very fluffy, it's quite watery, and that's the typical discharge that we get from a non-aspirated sprinkler. I've just moved through this video from a time point of view. So again, that fire pan, we're applying the foam, we're stopping the vapors from escaping, and eventually we get extinguishment by covering the whole pan with foam. In this situation, it happened about 3 minutes from ignition, and we get 5 minutes to extinguish the fire. So in this case, we had a very strong performance, extinguishing in 3, we had 5, and the good thing is we can carry on applying foam up to 5 minutes. Afterwards, we have a series of tests to check that vapors aren't escaping. Then later in the test, we're going to remove our foam blanket and expose the acetone to the atmosphere again. And then we're going to ignite the acetone again and then remove this pot. And then we must be able to keep that fire or extinguish the fire again for a further 5 minutes. So this test in total takes about 26, 27 minutes. And on that video, that was a very good pass. However, what I want to show you, just to explain why there's so much detail when it comes to sprinklers, is that we tested a different kind of K115. It's still a Viking sprinkler, still an upright. The flow rate was the same. Every single factor was the same, apart from the design of the deflector. And after 3 minutes, we've still got a much greater fire. But after 5 minutes, we did eventually extinguish the fire. And we got about 15 seconds of foam discharge before the 5 minutes was up. So you can see when we went to the burn back this time, we have much less foam blanket. And what happened was when we removed the pot, we got a fire spreading around the pan. So you see the foam blanket is much, the thickness is much less. And then as we move around the pan, our foam blanket has disappeared and we've got a fire. So this is an immediate failure. That's the difference between the two sprinklers. So the sprinkler design working with the foam can have a significant impact. It's not the end of the world. It just means that we need to apply more density. As a manufacturer, we're always trying to pass tests at the minimum possible density because that's what makes systems more affordable for you. Sometimes we need to increase the density, and that's the reason why. So when it comes to transitioning sprinkler systems, again, the questions we're going to be asking is, what's the existing sprinklers? If the Viking sprinklers, are they approved with the fuel or representative fuel that's been stored in that risk? So is the original density, how does it compare to what our new approved densities are? Like I said earlier, that can be different due to standard changes, not just an inferior fire performance. What height are the sprinklers installed at? We do see a difference in performance at higher heights. It's more challenging at a higher height. The foam has got to fall much further through the heat and flames to get to the burning liquid surface. If it's a commodity that we don't have an approval for, do we as a manufacturer have other test data to prove or to give you a design density for that? What I would say is that if there's a small amount of sprinklers that can be easily replaced and they're a different manufacturer, then that's something that can easily be done as part of the transition project. If, however, it's a manufacturing process with 1,000 sprinklers in the large manufacturing room, if they can't afford any downtime of that facility, then it may be that we want to fire test with that particular sprinkler and the chosen foam concentrate. So there's some of the pragmatic solutions that we've got to giving the right kind of trust and verification of system performance. Here you see an example on IPA where with a fluorinated foam, for example, we had an 8mm density with a K80 sprinkler. And then with a fluorine-free foam, we've had to increase to 12mm. So this is an example of an increase, but we also have examples where fluorine-free foams are working better. So in the past, with our fluorinated foam, we could only pass with K80 sprinklers. Now we can pass with K80, 115 and 161. So it's not always bad news moving to fluorine-free foam from a fire performance point of view. When we look at other discharge devices like foam makers, foam chambers, again, it's normally the foam concentrate that the end user, the insurer, selects based on its approval. So is it FM or has it got a UL listing? So then when we then look at the discharge devices on site to see if they have any approvals with that particular foam concentrate. Not only that, does the site discharge pressures at the outlet fall into the range of that device as well? What I mean by that is if you look at this is a typical listing, and it's giving you an inlet pressure range. I'm just trying to There we go. Just highlight that. So we've got an inlet pressure range. So this one is between 50 and 150 psi. So that's very flexible when it comes to ensuring we've got the right kind of discharge pressure on site. However, we have some manufacturers that only have one pressure. So is that going to work at 150? Is it going to work at 50? We don't know. They don't know. It's not been tested. So this is the detail of the approvals that's important for you if you're involved in designing and specifying products. These are the things you should be checking to make sure the solutions you recommend are fitting with the design requirements and the client requirements. I'm just going to skip through the rest of that page. This is quite confusing information, so we've recently enhanced our data page to make it much clearer on flow and pressure where a particular device can be used with a particular fuel and giving design densities as well. Like with the sprinklers, I would suggest that if there's just 3 or 4 foam makers, that they get replaced. If there's 2 or 3 foam chambers and they can be replaced, then take the opportunity to get something correct. If there's hundreds of these devices, then again maybe it's cheaper as a pragmatic transition project to run specific testing with what they have on site with the new foam. Again, we ask a series of questions, and these are the things that we recommend sometimes. This level of diligence or this level of attention is required. I mean, it always has been, but now the safety factors that we have with fluorinated foams, I've said they're passing the same test as fluorinated, but the pass-fail mark is generally more prevalent. So we need to make sure we use approved products, but also use them in line with their design approval. What I want to show you quickly is I spoke about foam qualities. This is basically expansion and drainage. I'll just play the videos while I'm talking. What we've got here is a fire test to qualify a foam maker or a foam chamber. The top video is taken with foam produced at 75 psi, and the bottom video is taken is using a foam quality produced at 40 psi. So what we've got at the top is a much more expanded foam. And you can see just already in the video that we start to control that fire. I'll just move it forward a little bit from a time point of view. So again, you saw this kind of video earlier, and we're now controlling the fire on the top video, and eventually we get extinguishment. In the bottom video, we didn't even get control. Okay, so this is the same test, the same fuel, the same density, but we're just using a different expansion of foam. So that's why it's so important to not only use approved products, but use them in line with their approval, the discharge pressure requirements. So this is still an FMUL approved foam at the bottom, but because we had too low expansion, that foam blanket did not work. Monitors we are seeing a lot in transition projects. Generally speaking, as manufacturers, we don't test so much with monitors and foam. And it's because it's very expensive, but there's a very high degree of variables. We can have different angles of the monitor. We can have a full jet. We can have a fog. And it just makes testing very expensive. What I would say is that if you're looking to select products, obviously look at UL, FM, and ensure that there's a certain amount of topside data with those with some devices. If they've got it with monitors as well, all the better. I know there's at least 2 manufacturers that have got fluorine-free foams UL listed, for example. What I would say is that if you're working on a project that's using a self-inducting nozzle, so this is a monitor that sucks the foam up from a local foam reserve. Firstly, I don't think it's the best solution anyway, but that aside, the original nozzle configuration and orifice will need to be checked, because if we're using a different viscosity of foam, perhaps the hose going to the foam container can't be as long. We will need some form of verification that monitor can work with the new foam concentrate. And of course, when it comes to the disposal of foam, we need to ensure that that is dealt with through waste treatment authorities. Okay, so that just can't be thrown down the drain. No surprise, but it's getting more and more expensive to dispose of PFAS-based foam. The only way to really do that is through high temperature incineration. So that's, again, another consideration to make. I have skipped through lots of other discharge devices because we don't have so long today. But that's us going around the system. From our point of view, we get involved not really as a consultant, but just offering guidance about the products that the client has on site today and what challenges may be faced when making that system both compliant but also legally PFAS free as well. I've got several case studies, but I'm just going to use one today. This was a project we came across where the customer complained that the proportioner no longer worked. What we discovered was they'd emptied the tank of AFFF and replaced it with a fluorine-free foam, and they did probably everything wrong. They didn't replace the bladder, so they've now got contaminated fluorine-free foam. They didn't clean any of the pipe work. They didn't change the proportioner. And worst of all, they didn't select an FM approved foam. And this is an FM global site. So they've now got to replace and do all that work again. So my whole presentation is to just ensure that you don't make these similar mistakes. So when we look at the overall picture, this is my last slide. When we look at the overall picture and trends and predictions for the future, this is my personal opinion, not those of industry or my employer. But what we see is that North America and Europe are very much on a path to legislating against PFAS in firefighting foams. This is already leading to many SFFF systems being installed. We even see, while projects are ongoing, they're taking the opportunity to work with fluorine-free foams. This is becoming much easier because there's more manufacturers to choose from, and those manufacturers have more and more approvals and solutions available. Because of that EU legislation, it's likely that by 2028, the use of any type of fluorinated foam will be prohibited. That doesn't mean that we can't sell it anymore. That means that it cannot be used anymore. So, of course, the client will always be okay as long as they don't need to use the system. But if they have a fire and there's contamination due to PFAS, that could be an issue for that end user in the future. We see in North America this timeline moving much quicker. State by state, it's different. Other countries will follow. So I've spoken about Europe and North America, but the overruling, if you like, international law is coming from the Stockholm Convention, and almost 200 companies globally are signed up to that. And it's a part of the Convention on Persistent Organic Pollutants. And PFOA, for example, is now banned. So even if you're not in Europe or North America where there's specific legislation, your government has an obligation under the Stockholm Convention to start to deal with this this issue. Additionally, there'll come a point where phone manufacturers, where it's not economically or legally or physically possible to produce fluorinated type phones. So even without regulation, they will be forced to produce more and more SFFF alternatives. And actually, without naming names, but the biggest fixed foam manufacturing company in the world, they've now stopped the manufacturing of fluorinated foams. Other big companies have also announced that they will stop supplying fluorinated foams. That's because of future risks of litigation, but it's also because the new fluorine-free foams, we're now getting, very good products with performance similar to what we had before. And of course, innovation and chemical formulations will continue to improve. And I just want to finish by saying that firefighting foams are still the most effective solution when protecting Class B ignitable liquids. So although some end users would prefer not to have foam at all, it is still the only way of protecting certain fires. Okay, so that concludes my presentation today.
Teşekkür ediyoruz Simon Barrett'a. Ben soruları alacağım. Bu arada bir soru geldi ama başka sorular da var mı? E, Sorumuz şöyle. SFF köpük yüksek genleşmeli köpük sistemlerinde kullanılabiliyor mu? Soruyu soran Levent Karakoç + Yangın Danışmanlık.
Okay, thank you for the question. High expansion foam concentrates for the protection of hydrocarbon risks in aircraft hangars have generally, most of the mainstream foam concentrates were already without PFAS inside. So if you're protecting an aircraft hangar, for example, you can be 99% sure that foam, even used in the past, was PFAS free. If the high expansion foam is used in chemical storage, for example, instead of sprinklers, then there are new fluorine-free versions available for high expansion systems. Our company has one of those with some European approvals, but it does need to be a specifically manufactured to give high expansion and stability. But yes, there are fluorine-free solutions available for all types of high expansion system.
Başka soru yok mu? Yoksa benim bazı sorularım olacak. Sorular şöyle. Mesela raf ömrü. Diğer köpüklerde belli sene vardı. 10 sene mesela süresi vardı veya üreticiye göre değişiyordu. Raf ömürleriyle ilgili herhangi bir yanıt verebilir misiniz? Bir de başka bir şey soracaklarım devam ediyorum yine. Derecesi. Donma derecesi. Yani daha önce e, donma derecesi farklı olan mesela -6 veya yüksek dereceli düşük derecelerde donmaya karşı dayanıklı köpükler vardı. Bu konuda bir çalışma var mı? Veya durum nasıl SFF köpüklerde?
Yeah, so for the freezing point, that's the easier one first. So there are products available with, minus 10, minus 15 Celsius. That's just a case of adding antifreeze glycols to the foam formulation without taking away the fire performance. So as we had in the past, there are freeze protected and low temperature versions available. No issue there. Regarding shelf life, there's obviously an official answer I can give, but I'll give you the honest answer. When you look at manufacturers' data pages, it will say, as you mentioned, typically in excess of 10 years if stored in the right conditions in the original container and lots of small print. I have two observations. Firstly, that fluorine-free foams are a lot of these formulations are not 10 years old yet. Now, manufacturers do simulate accelerated aging in tests to simulate 10, 15, 20 years over a period of a few months. But in reality, a lot of these new generation foams are still only 3, 4 years old. So I think it's very important that they're stored in the right conditions. So the atmospheric tank I referred to earlier, we need to make sure it's out of sunlight. We need to make sure it's in a stable environment because if we have a fluctuating temperature, we might get condensation, which or evaporation, which will affect the foam's stability. That was true with AR AFFFs. The big difference is we've taken away that forever chemical, the PFAS, and I think we'll only know long term how much of an effect that has as well. So we've simulated shelf life in excess of 10 years. Some test standards, such as FM, they actually retest that stability as well. But my biggest advice to everyone is to really concentrate on ensuring, it doesn't matter if it's an atmospheric storage tank or a bladder tank, ensuring that it's out of sunlight in a temperature controlled room. That is going to give you the best chance of that foam performing on year 15 as it would in year 1.
Diğer bir soru var. Ee, SFF köpüğü her sene test etmemiz gerekiyor mu? Kalite ve regülasyon nedeniyle. Herhangi bir regülasyon var mı? Yani gelen şeyi bilmiyoruz çünkü eskiden normal köpüklerde AFFF veya da ARFFFF belli bir oturmuş standart vardı. Bu köpüklerin senelik bir testi yapılması gerekiyor mu performans testi anlamında? Teşekkür ediyorum.
Yeah, good question. I don't know if you have your own local standards, but certainly EN and NFPA standards, there's no differentiation, there's no difference between fluorinated and fluorine-free. So it's always been a recommendation, requirement to test the foam concentrate annually. With fluorinated foam, perhaps we was a bit lazy in the first few years, but certainly when it's beyond 5 years, we would recommend that be done. And with fluorine-free foam as well, we recommend it's done every year. So I guess my short answer is we would recommend that the foam concentrate is tested every year.
Teşekkür ediyorum. Başka soru soran var mı? Eğer yoksa ben soracağım. Devam edeceğim. Yok şu anda. Ben sorayım o zaman. Deniz suyu ile SFP köpükleri karışımı ile
Yes,
ilgili ne düşünüyorsunuz? Yani öyle mümkün müdür deniz suyu ile karıştırmak? Ama etkisini bozuyor mu?
yes, it is possible. And when when you run approvals with FM, UL, and even to the EN standard 1568, it will there's a test with freshwater and also a test with seawater. And then in the approval or in the certificate, it will confirm the performance with both. And it may be that with some fluorine-free foams, the performance is not good enough with seawater. So they may only have a freshwater approval. But yes, you can get fluorine-free foams that work with seawater.
Teşekkür ediyorum. Başka bir soru soracaktım. Son müşteriye veya yatırımcıya bu konuda Avrupa Birliği'nin veya Dünya Bankası'nın herhangi bir teşviği oluyor mu finans anlamda? Çünkü gayet yüksek miktarda bir sorumluluk geliyor. Stockholm Anlaşması'nı Türkiye'de imzaladı. Resmi gazetede yayınlandı. Şu anda henüz ciddi olarak bir şey görmedik ama yakın zamanda Avrupa Birliği ile beraber Türkiye'de bunun etkilerini belki görmeye başlayacağız. Dolayısıyla e, soracağım soru finansı.
That's a good question. It's the first time I've been asked it. I have not heard of any government or international funding being available to take care of this transition. It's a good question. I'll do some research on that, but I've never come across that situation. It's always been the end user that needs to comply, and therefore they need to spend the money themselves.
Evet. Ne diyorsun başka? Tam bitirelim mi? Başka soru soracak var mı? Simon arkadaşımıza yorduk. Herhalde artık sormayalım veya bilmiyorum son bir soru gelir mi? Bekleyelim isterseniz bir soru gelmiş, evet. Özkan Yıldırım. SFF köpüğünün SFF köpüğünün Newtonları olmayan akışkan özelliğinde olduğundan bahsettiniz. Kullanılan hidrolik programlar Newtonları akışkanları özelliklerine göre çalışıyor. STP köpükleri bu programlarla ya da yaklaşım ile çalışmak ne kadar doğru sonuçlar doğurur? SFF köpüklerin ampirik testler ile sonuçları bu konu ile ilgili mi?
Yeah, yeah. So it's just the foam concentrate pipework where we need to take care. So hydraulic programs cannot be used for calculating the pipe from the tank to the proportioner because it's got a non-Newtonian liquid. And what NFPA, for example, will tell you is refer to the manufacturer for their specific pressure loss data. So manufacturers, I must admit, we have still not published ours, and not many manufacturers have this data. But for the foam concentrate line from the tank to the proportioner, you should ask the manufacturer to give you the data. Once the foam concentrate is mixed with water, it's 3% foam concentrate, 97% water. So downstream of the proportioner into the system, that can still be calculated with your standard hydraulics programs. We assume the same characteristics as water when it becomes a foam solution. So just from the foam tank to the proportioner, that cannot be calculated with hydraulic programs.
Diğer iki tane sorumuz var. Birincisini sorayım. İtfaiye araçlarında nozzle gibi değişiklik yapılması gerekecek mi?
The refinery trucks would need to certainly have the proportionate. The fire trucks, they would need to have their proportioning system checked that it can still deal with the higher viscosity foams. When it comes to the discharging on a fire truck, what we need to remember is there's a human at the end of the hose. So in real time, the fire person can increase flow. They can increase the percentage of the foam based on how they're tackling the fire. So I think with a fire truck, it's more the proportioning system and the storage tank on the truck rather than the discharge device, which is the area of concern.
Bir sorumuz daha var. SFF köpüğünün insan sağlığına zararları, uzun süre maruz kalma, itfaiyecilik mesleğindeki ilgili bir çalışma var mı? Disi daha kolay bir soru diye düşünüyorum. Ben de ilave edeyim. Tekrarlayayım isterseniz, almadıysanız.
I
SFF köpüğünün
No,
insan
it's under. Sorry, it's understood. I didn't know if you was going to ask another question. Um, from my perspective,
Teşekkür ederim.
I'm not aware of any studies that have the same concerns as fluorinated foams. I must admit the deep chemistry is not my area of expertise, but fluorine-free foams are still a chemical at the end of the day. They still have toxicity, they still have chemicals in there that have an effect on the environment. Whether they have a long-term effect on humans, I really don't know, because they do biodegrade 100%, and that's the main difference between the two. So um, my feeling is no, but I cannot answer that question 100%. I'm sorry.
Anladım. Başka bir soru daha var. Hı? Yok mu? Yok. Bir de senin korozif etkisi ne vardır? SFF köpüğünün korozif etkisi konusunda ne düşünüyorsunuz? Ya bir de mesela galvaniz boruyla herhangi bir tepkimeye giriyor mu? Mesela galvaniz boru kullanılmaz köpüklerde aslında biliyorsunuz siz de ama SFF köpükte ne olursa galvaniz boru içinden geçerse.
Yeah, the same requirements and recommendations under design. It's the same for fluorinated and fluorine free. So we're not using galvanized pipes for foam concentrates. They will still have the same effect of removing the galvanization and risking plugging of orifices further down the line. In terms of corrosion, we don't see it any worse or any better than foam concentrates before. So we should always, for the foam concentrate pipe, we should always use stainless steel or brass or any other material that the manufacturer has proven to work. So HDPE pipe, I know some people use that. So there's no difference between the foams. If there's a discharge of a system, due to an accidental release or due to a fire, we would always recommend washing down both internally and externally on the system. If the foam's left there, it will have a corrosive effect on metals. But there's no, from what I've seen, there's no great difference between fluorinated and fluorine free. So we should still clean up after any kind of test or discharge.
Son bir sorum var. Geçmişte biliyorsunuz, duymuşsunuzdur. Sandos faciası vardı. Nehre karıştı. Köpük ve balıkların ölümüne neden oldu veyahut da zararına neden oldu. Bu SFF köpüğü aynı şekilde bir nehre boşalsa Balıklara ölümü söz konusu mu veya bu konuda çalışma var mı? Canlılara etkisi anlamında.
Yeah. So in that same scenario that you mentioned, if a fluorine-free foam was discharged, it would have probably had the same effect. The reason for that is it's not the chemical directly on the aquatic life on the fish. It's as the product is biodegrading, it consumes the oxygen inside the water. So if there's too much foam and foam solution compared to the volume of water, and too much oxygen is consumed, that's what is affecting the fish. So, like I said earlier, my company does not call this product environmentally friendly because it still has an impact on the environment. The key thing is it doesn't have a long-term effect like the fluorinated foams do.
Bunu da söyleyebiliriz. Toprağa da bu SFF köpüğünün girmesi zaman durumunda aynı şekilde sorunlar başlayabilir. Toprağa karışması durumda. Mesela Amerika'da bildiğim kadarıyla ya şeye haber veriyorlardı. E, Arıtma tesislerine haber vermeleri, EPA'ya haber vermeleri gerekiyordu. Veyahut da en basit çözüm güneş altında e, atığın bozulması şeklindeydi. Ama bu tabii çok iptidai bir çözümdü. Sanırım burada da aynı problemler söz konusu.
Yeah, and the thing we've got to remember that between fluorinated and fluorine free, it's when the foam gets into soil or water, the key difference is fluorine free will degrade to 100%. It will not leave any of those PFAS chemicals behind. Whereas with fluorinated foam with PFAS, if that gets into the soil, then the PFAS will remain. When the rain comes, it can transport that PFAS into the water source. So these PFAS chemicals, they're very resilient. They don't break down in the environment. That's why they were so useful in industry to improve the performance of different types of products. So I wouldn't say SFFF foam going into soil is any worse than fluorinated in the short term, and in the long term, it will be much less of an effect because it doesn't have those forever chemicals.
Tamam, teşekkür ediyoruz değerli konuşmanı için. Çok teşekkür ediyoruz. Ben kapatıyorum. Katılımcılara teşekkür ediyorum. İyi hafta sonları diliyorum. Teşekkürler.
Thank you.
Thank you.